151 is learning about different types of representations or ways we can represent different things. And there's two types. There's concrete and abstract. And if you think about concrete and just the word concrete and what it means, like parking lots are made from concrete. The foundation of buildings are made from concrete. It's solid, it's sturdy, you can touch it like that, and that will help you understand what a concrete representation is. It's anything that you can physically touch. Blocks are an example of concrete representation, as are any model or tiles or marbles, anything like that that you can physically touch and move. So concrete means you can touch it and manipulate it or move it around. Abstract, anytime you hear the word abstract, it's more theoretical. It's just sometimes, a lot of times, it's described as an idea. Now, in math, we don't really have ideas, or we do have ideas, but that's not what we're talking about when we talk about abstract representations. We're talking about things that you can write on paper. Like you can write letters, not a letter you write to a friend, like letters A, B, C, D, or numbers, graphs, tables, anything that you have to physically draw on paper. Yes, you can touch it, but you can't actually, when you touch it, move it around or anything like that. So, there's a couple examples we have down here. A verbal description is a blank representation. Well, verbal means words, and so that's going to be abstract. A model, as we said earlier, is concrete. And a picture or a drawing, well, that's not something we can actually touch and move because it's, drawn on paper, so that's going to be abstract. So a good definition of abstract may be to say that it's written or drawn. All right. The next page. We have some more questions. A table is that's going to be an abstract representation because, again, it's something that can be drawn. And when we talk about a table, we're not talking about like your dining room table or your desk table. We're talking about like a T-chart. A bar graph is also an abstract representation. And lastly, a pie chart is also abstract. Again, these are all things that you can draw. Okay, so there's different ways we can display data. We can start with a table. Table is going to be something like this. You have numbers on both sides. So there's some advantages and disadvantages to having a table. One of the advantages to using a table is it's best for finding exact values, because the table will always give you exact values. A disadvantage is that it's hard to have if you have a lot of data. So it's not good for lots of data. Like if you were trying to make some sort of representation to display the batting averages of all the Major League Baseball players. Well, there's thousands upon thousands of Major League Baseball players, and so you would not want to write every single one of those numbers out. So our next one is a bar graph. And bar graphs look like this. Notice that my bars are not connected. That's the important thing there, okay? In a bar graph, the bars are not connected. A bar graph is great for showing changes over time. So if you wanted to compare how one person did in their monthly sales, a bar graph would be great for that. And it's also great because it can compare more than one set of data. Bar graphs, the disadvantage to them is that they usually require some explanation. You have to label everything. You can't just draw a bar graph like this one that's drawn over here and walk away. You have to tell me what each bar stands for. And you have to tell me on the sides what the axes stand for and what the increments are. And there's a lot of information you have to provide. Next page. We have pie charts. Okay, pie charts are circle graphs where you have, slices cut out. And those are great for comparing parts to wholes. They're really great for percents. That's what we usually use them for, is anything with percentages. The only problem with those is they typically don't provide precise data values. They don't usually give exact values. In other words, most times when you have a pie chart, people don't actually write the percentages in them. It's just a visual for you to look at, and so you can see which section is the biggest and which section is the smallest. So, we've already talked about a concrete representation. An example of a concrete representation would be something like using blocks. A pictorial representation. Well, if you think about the word pictorial, the root word in there is picture. And so that would be drawing a picture. A graphical representation would be a bar graph or a pie chart, because it's a graph of some sort. A symbolic representation means we're using symbols. Well, that's usually going to be a formula. And a verbal representation, well, verbal is going to mean words, so it's going to be written using words. So just remember that concrete means it can be touched and moved. And anything else like pictorial, graphical, symbolic, verbal, all of these are going to be abstract because they have to be written or drawn. You can't actually move them. So moving on to your checkup. All right, number 1, which of the following is not an example of a concrete representation? So concrete can be touched and moved. Well, blocks, I can touch and move those. A bar graph, I cannot touch and move those. Tokens, I can touch and move those. And tiles, I can touch and move those. So a bar graph would be the one that's not concrete. Number 3 says, is the following table a concrete or abstract representation? Well, to figure that out, ask yourself, can you move it? Or is it written? That's really the 2 questions. And this table is something that's written, so that makes it abstract. Number 5, is the following a concrete or abstract representation? So if you look at the next page, it's talking about this bar graph over here. This is number 7. And it wants to know if it's concrete or abstract. Well, again, the question is, can you move it? Or is it something that had to be drawn or written? And the fact is that it's something that had to be drawn. I'm sure a computer did it, but you could easily draw it as well. And so that makes it an abstract representation. I'm sorry, this is question 5, by the way, not 7. That makes it abstract. Moving on to number 7. The question asks you, says the parents at a high school have offered to spruce up the playground area. They need to do a number of projects, including sowing grass seeds. They also need to present their plan to the PTA so that it can be approved. To determine how much grass seed the parents would need, what kind of representation, verbal, model, or picture, etc., would you choose to use? And there's really no specific answer for this question because you could kind of use whatever you wanted. Personally, I think a picture would be the best option. And the reason I would pick a picture is because I could draw it, and then I could draw a scale model showing the areas and then figure out how much grass seed would be needed.